Hello, welcome to lesson 11.6. This is our fifth and final lesson on trigonometry. We are looking at today how to translate trigonometric graphs. So today's goals are to graph horizontal translations of trigonometric functions, okay, so just meaning moving things left to right on the graph, and to graph vertical translations. So kind of a soft landing for this difficult unit, I think. So we've got what we call a vertical shift, so that's just up and down, and then what we call a phase shift, which is going to be left to right. It's called a phase shift. You're talking about like you can discuss trigonometric functions as having like cycles, up, down, back up to where you started on the sine graph, and where you are in that cycle can be referred to as what phase you're in. Are you in the starting phase? Are you in the final phase? Are you somewhere in the middle? So shifting a graph that is a trig graph will kind of shift where you are in the phase of that graph. So first of all, just to kind of get started playing around with things, I would recommend that you open up Desmos and just kind of mess with this on your own so that you can kind of gain that intuition for how this works. But really, we end up with what we've seen all along. If we're moving things left to right on a function, we're going to do so by adding or subtracting from the x variable. So if we actually hopped back, not looking at sine ones first of all, if I just did like y equals 3x plus 1, if I wanted to shift this graph 2 units to the right, so I want to arrive at, let's say for example, this point, I want to move it 2 units to the right, get it over here. Well, that means that I need to be putting in an x value that is x value of 2 and getting out the same result as when I put in an x value of 0. All right. So the way that we do that is we just say minus 2 over here. In order to get that same result, you would need to put in an x value that is 2 larger than before. So to get to this point, we're not going to say 0, 1 anymore. We're going to be at 2, 1. Okay, we get that because we do x minus 2. And when we put in a number that's not twice as large, but 2 units larger than before, we end up at the same place. So if I wanted to get to that output of 1 and I wanted it to happen when x equals 3, well, then I'm just going to say minus 3. Okay, now it's happening over here. Same thing in the other direction. If I add 3, then I shift to the left. Okay, so these are all kind of the same things that we're going to see with the sine graphs. Now, the sine and cosine graphs can be a little bit harder to interpret what you're looking at, just because they do kind of repeat. And as we shift them over, you can end up not really noticing what's changed. So, for example, if I have sine of x and I do minus pi, that is going to shift everything over by pi units, by 3.14 units. So rather than having an intercept here at pi comma 0, we're shifting everything back, and we have our intercept here at 0, 0 on the green line. Let me try to do this a different way. So let's do a smaller shift. Let's say we're going to subtract half pi, or a quarter pi, or an eighth pi. So any of these numbers, any of these subtractions, right, we're moving our blue line, we're moving our sine graph towards the right. So if I want to do 1/8 pi, I move it to the right a little bit. If I want to do a quarter of pi, I'm moving it to the right even further. If I want to do half a pi, I'm moving it to the right even further. And if I want to do a full pi, well, then I move it so far to the right that this portion that was kind of rising through the origin is now showing up over here, a full pi rotation over to the right. So one thing to notice when you do this is that if you are changing by the right amount, so let's try to get the right amount in here. What do I do? Let's try plus 0.5 pi. Is that right? Yes. Pi over 2. So if you rotate by pi over 2, if you shift your graph over by pi over 2 units, you'll go from what was originally a sine graph and create a cosine graph. So cosine of x is equivalent to sine of x plus half a pi. And if I take this one out, we end up with both lines just being totally overlapping. If I go in the opposite direction, I get a graph, this green line here, that looks like negative cosine, right? If I put a negative in the front here, we could flip it over and get them to overlap. So I would, like I said, I would recommend that you get on Desmos yourself and you just kind of play around with this. Like open up two graphs, one of sine and then one of sine where you are doing some sort of horizontal shift. So you're either adding some amount of pi or subtracting some amount of pi. It needs to be in terms of pi right now. You can change that on Desmos. If we go to the graph settings, you can change it 2 degrees. Which might not be a bad idea. If you do that, you'd want to switch your axes up so that they fit the graph better. So I would say, go from negative 360 degrees to positive 360. In this case, the shifts that I would do would be more like x minus, let's say 180 degrees or minus 90. So I think that one's easier to look at. When you do minus 180, it kind of just looks like your graph has been flipped vertically. It looks like we've taken like this peak and moved it down. That's actually not what's happened. We've moved it to the right by half a cycle, but the effect that has is that it looks identical to if you flipped it vertically. So the easier one to practice around with to like get a sense of things, I think, is when you subtract 90 degrees or when you add 90 degrees. Okay, with that one, it's a little more clear to me that we're just moving to the right by 90 degrees. All of my points along that sine graph have been shifted to the right by an order of 90 degrees. So whereas before we're at 90 at the peak, now we're at 180 at the peak. Okay, but that's really all there is to it with the horizontal translations, is that just like any other function, if we add or subtract from our variable, if we do x plus 90 or x minus 90, that's going to shift our whole graph to the right and to the left. That is all explained in the book here. So it says a horizontal translation of the graph of a trigonometric function is called a phase shift. The phase shift of the functions y equals a sine b of x minus h, y equals a cosine b of x minus h, and y equals a tangent b of x minus h is h, where b is greater than 0. So they're just saying that your phase shift is determined by this value of h in here. So when it says if h is greater than 0, the parent function is translated to the right. So if we're subtracting some amount, like subtracting 90 degrees, we move to the right. If h is less than 0, they're basing this off of like the standard form being x minus h here. So if h is less than 0, then we're subtracting a negative number. In effect, we're doing x plus something, and we move to the left. So standard things that we expect: when you have x minus some amount, it moves to the right. When you have x plus some amount, it goes to the left. And that's really all there is to it on our horizontal shifts. So we will move forward in example number 1 in the next video to try to get some experience playing around with these.